Well, hello everyone, and welcome to the Observation Lounge here at Station 204. We got a lot of exciting stuff to talk about today, so let's just go down the line. Sarah, what you going to be talking about today?
Killer radiation from outer space.
Oh my gosh. What about you, Jade? What do we got?
Welcome to space, Spaceship 2.
Oh, finally. And Athena, what have you got?
There was a star that was born from another star.
What? That makes the star from... Okay.
Starception.
And then, Mike, what have you got today?
There was some exploratory surgery in space on a spacecraft.
Yeah. And then a little bit later, we'll be joined by our guest in studio, Jim Adams, the former chief technologist of NASA. And maybe a little bit later in the show, we'll go a little Interstellar. Does that sound good to everybody?
I think I dressed appropriately.
Yeah, all right. So, this is tomorrow, Orbit 11.49.
Good morning. How's everything up in the sky?
Oh man, we have got a lot of cool stuff to talk about today, but unfortunately, a thing that we usually talk about that starts off the show, launches, ain't nothing. So, can you believe this, Mike?
No, we didn't have any this week. We didn't have any orbital rocket launches this week. We did have an attempt, but it wasn't actually, it was scrubbed, but so it didn't actually take off the pad. So we didn't have any orbital rocket launches this week.
I am so disappointed in the Earth this week. You all have failed me for the last time.
He had one job.
Yeah.
One job.
So, we're going to go ahead and move right into our stories. And Jade, we're going to get started with yours because there was something really cool that just happened recently.
It just happened.
Yeah, this still counts as a rocket launch. We're still starting off the show, right?
Yes.
So instead of a launch minute, it's going to be a launch few minutes of Jade trying to explain something. So yes, we want to give a big congratulations to, that fell off, Virgin Galactic for launching successfully Spaceship 2 into the edge of space. As you can see right there, this was a successful flight, and we have some beautiful footage. You can see it here. Dropping off from White Knight 2, firing off its very fiery little engine, and look at it go. That is just beautiful.
Oh my God.
Spaceship 2 did reach the edge of space, which we're probably going to talk about a little bit in terms of what that actually is, but it reached 82.7 kilometers, about 51 miles above ground. Oh, look at that. I'm not going to lie. When I saw Branson tear up, I teared up.
Yes.
And it was an emotional moment we shared together. Now, this is the highest and fastest that it's ever flown since it started flying back in April of this year. We want to give a big congratulations to the pilot in command, Mark Forger-Stuckey, and the ISS's CJ Sturcow. That's them right there, looking at Earth. So beautiful.
Holy moly.
Yeah.
Wow.
Oh yeah, look at that.
I don't even want to talk over this. It's just so mesmerizing.
Yeah.
I'm just going to go ahead and let it,
Let it have a moment.
Are incredible.
Yeah, those are the Sierra Mountains off to the right.
That is gorgeous. Yeah,
Wow.
You can see that curvature. Hey, look, Earth is round.
If this
Who'd
isn't
have
an
thought?
overview effect, I don't know what is.
How about that? You can see it right there.
Oh, man.
Look at that.
Fake news.
Then I believe, I don't know
This
if,
flight has been, we've been waiting for this flight for a long time, though. I mean,
Yes.
when Virgin Galactic first got started in 2004, they were hoping to have this flight happen in like 2009. They had so many problems with the engine. They had to redesign that engine so many times.
Yeah.
exactly. But look at it now. And so in case you're not familiar with the way it works, essentially Spaceship 2 is carried into altitude by White Knight 2. And essentially it's basically dropped where its engines start to kick in and takes it the rest of the way. And as it comes back down, it does this really cool feathering maneuver that basically allows it to land like this. Land like a kind of like an aircraft you would see land very gracefully and successfully. Nobody was hurt. In fact, there's a lovely photo of Branson and the two pilots. I think we have it in there that I really wanted to share. Just look at how triumphant that is. That is just gorgeous.
Look at that.
So as I mentioned, its rocket engine switched on for actually an entire minute, and that's 18 seconds longer than the previous launch. It took it beyond the stratosphere, and it reached about 1,800 miles per hour at its top speed, which I'm sorry for everyone else, 2,900 kilometers.
Whoa.
Which, yeah, pretty fast. I think like Mach 2.9 or
Yeah,
whatnot.
that's cooking.
2.5.
Oh yeah,
So-
for sure.
Yeah.
And there was a little bit of debate, like, well, did it reach space? Because the Kármán line is 100 kilometers. But then Ben actually mentioned right before the show that the Kármán line was never actually meant to be the definition of the beginning of space. In fact, it was just basically supposed to determine when lift absolutely has no effect anymore. Correct?
Yes.
Yeah. So.
And it's not 100 kilometers.
No, it's not.
And it's not
I was
even
gonna
100
say,
kilometers,
I brought it up
right?
just now. It is 83.6 kilometers.
And it fluctuates.
And I just want to say this. That was calculated by Theodore von Karman himself.
Wow.
You cannot argue with the man whose name is on the line
on the
who
darn
did
line.
the calculations. So,
One more
And
time.
Spaceship 2 got to 82.7 kilometers, so they were almost there.
yes.
Yes.
Hey,
So-
man, that's space.
Absolutely, and
It's
I was
space.
going to
It's
mention,
space.
and at that point, beyond 80, I think, is when NASA and the Air Force award their astronaut wings to pilots. So they got their wings, which is great.
course.
So I mean, if it's good enough for them, it's good enough for me. And so what was aboard this? The payload was the 2 pilots as well as some experiments from NASA, about 4.
Yep.
And those experiments are going to do some really awesome science, but it was also, I believe, meant to simulate having additional passengers, additional weight on, if I'm not mistaken, on the actual vehicle itself as to simulate, a commercial group of people going in. And in terms
Yeah.
of testing, I think they're going to be testing again as soon as maybe next month. And Branson wants to be aboard it for the first commercial flight next year.
Nice.
So this is all
Wow.
moving quite quickly now that this was successful. And this is really exciting. If you still want to buy a ticket, I believe they stopped selling them. They're about $250,000, but I think they're going to start selling them again next year. So,
Nice.
Yes.
you
Let
know,
me,
start
look through my
pinching
couch.
some pennies. Yeah, just look under your couch, look into your
Yes.
old pockets,
Yeah.
past all the gum wrappers and stuff. You might find $250,000.
One of my neighbors has a ticket, so it's pretty
Absolutely.
cool.
Wow.
Yeah.
And I mean, if you didn't know, this is actually a huge step for commercial space flight.
Yes.
The fact
Yeah.
that this was successful, I think it was the first manned commercial
Yeah.
company to get humans to that point, if I'm not mistaken. Right? Is it?
I
Yeah.
don't think so. No, Spaceship One won the X Prize,
Yes, it
and they
did.
put 2. Mike Melville flew twice. He flew the first flight on June 21st, 2004, and I know that because
Oh, the
I was
Source.
watching it, even though I was in high school. And they did the 2 X Prize flights in, I think it was September and October 2004. And all 3 of those flights exceeded 100 kilometers with Spaceship One.
Oh, wow.
But Spaceship One was by far a much smaller
Yes.
and much less complicated vehicle than Spaceship Two is.
Exactly. Exactly.
Wow.
And so,
Craft, maybe?
What's
that?
up?
First passenger craft?
Yeah, I would say
That's
first
probably
crude,
it.
Yeah.
Okay. I probably left out an important word at
first,
some point.
first crewed vehicle to cross into space, or first crewed tourism vehicle to cross into
Tourism,
space.
there we go.
There
So-
you go. This is
Yeah.
why we're a
That's
team.
Also the
Yes.
first crewed vehicle to cross into space from American soil since 2011 when the space shuttle launched.
Yeah.
for the-
Yeah, that too.
Yeah.
So
Yeah.
And it flew right out of Mojave Air and Spaceport, correct?
Yeah.
Amazing.
out in the
actually,
Mojave. So
Mojave,
that's
as
right.
the locals
So-
call it. And Ben wanted me to mention this. I actually had the immense opportunity to go to the Spaceship Company, or was it Virgin Orbit? I forget. Anyways, I got to go out there, and actually, I got to see Spaceship, I think it was Spaceship 2, feather and defeather in the actual big, what do you call the building?
Hangar?
Hangar,
Yeah.
yeah. Wow, was it exciting and loud.
Very nice.
And this actually leads us into a comment, and this is from the community, from Frida. Frida says, the recent 2018 December Virgin Galactic event of sending Spaceship 2 to 83-kilometer altitude is a notable achievement. My question is, the piloted Spaceship 1, from which it is cited the design of Spaceship 2 is derived, correct, reached plus 100 kilometers altitude 3 times 14 years ago in 2004. why today does it seem like there's a lot more attention to this current achievement? And Jared, I think you started to kind of answer that. There were certain milestones that were achieved.
Yes, there were, but Spaceship One was never intended for people like you and me to actually buy a ticket and take it on.
Exactly.
Spaceship One was basically Paul Allen chucked a bunch of money at Burt Rutan and said, "Figure out how to get this above 100 kilometers. We want to win the X Prize." And then everybody thought, "Oh, well, that was a piece of cake. Let's go ahead and do that." Which, by the way, if you read up, there's some really great documentaries about what it took to get Spaceship One going. It was not a piece of cake. It was a very long-term project.
Just make it look so easy.
Yeah, they did. They made it look like it was the easiest thing in the world, but that's because they put so much effort into making it happen. And yeah, this is just a huge achievement because people are going to be flying on this, and it's really exciting to me, at least, from the perspective of not just paying customers going to be flying on it and taking Instagram selfies near the window as the horizon dips by and the black skies behind them. To me, it's very exciting because this also opens up the realm of performing experiments that otherwise would have to ride share multi-million-dollar launches or pay for a sounding rocket in order to do things like this. Now you could just stick it on a Spaceship Two or any of the other suborbital vehicles that are going to be carrying paying passengers, and you can do your work there instead of having to, this opens up the realm of possibility, especially in universities and things, for students to fly their payloads and actually do what they want to do. And that's very, very exciting to me. And I also would like to make one more point, which is that a ton of people were complaining about the fact that it took Virgin Galactic 14 years to pull this off. I would like to say that Blue Origin, from the inception of New Shepard to the first successful flight of New Shepard, 15 years. So just want to point that out. So
And no humans.
yeah, and no humans. No humans yet.
Yeah.
So,
No meatballs.
which you could kind of debate as it's a factor, but yeah, that's for another show, I think. So,
Interesting.
yeah, very, very cool stuff.
Another way to look at the complexity of the two vehicles is Spaceship One. I mean, it only had one person on board, although I think it was designed to have two passenger seats in behind
For the
pilot's
X Prize, I believe you had to have one person and enough ballast to represent 3 or 4 additional people on board.
Interesting.
Okay. Yeah. In any case, though, there was only one person on board, so I like to think of it as like the Mercury capsule, which was just for one person. And then Spaceship Two has the 2 pilots and 6 passengers, so it's like going from a Mercury capsule all the way up to an Orion capsule or something even more complex than that. So there's a lot of work that has gone into these 2 different vehicles.
Yeah, and just want to say to our viewers who are watching now or watching on demand later, if you'd like to, in Orbit 10, we actually interviewed George Whitesides, the CEO of Virgin Galactic, and the suborbital is not necessarily where they're stopping at. So I want to jump into our chat because we've got some really good questions in here, which is let's just go ahead and have a go at it. One coming from YouTube from Arco Holistil, which is, why is the Karman line at 100 kilometers when von Karman actually calculated that it was 83.6 kilometers? So, well, I can tell you it's because it was arbitrarily set up at that time, basically, to start handing out prizes to people. So, yeah. The who's it? International
It's French,
Federal Nautical Aeronautique or something like that. Basically, it was arbitrarily chosen because it was a nice even number, and also beat the Soviets. Hey, that's sorry. I mean, come on. So that's what it was. I like this one from Luke. Thank you. There. Let's see, from Luke Bowering, talking sort of about us with that, which is suborbital man yells at Karman line. That was pretty good. Steve Sharmer in our YouTube chat is asking, will the passengers get to float around inside of Spaceship Two? And I do believe they will.
I think remember when we did an interview with Loretta Whiteside, she was mentioning that there actually is a moment where, because I think when she actually was going through a few different tests, and you actually can experience just floating for that moment, and then obviously you have to get strapped back down and then prepare for landing. So I believe that's something they're planning on and actually doing. So that would be really cool.
Very cool. From our IRC chat, 1 over Alpha has a very good counterpoint for my point that Blue Origin took 15 years, which is, but Blue Origin wasn't saying 6 months out for the last 10 years. So yes, I think we have to retire that joke now. Unfortunately.
Oh man.
Rest in peace.
Not yet. Not yet.
I guess technically.
They are still, in fact, 6 months out.
Astro YYZ is letting us know the FAI is the group under the Fédération Aéronautique Internationale. So there you go. That's the group with it. There's some really entertaining ones here. I know there was one here that was asking what kind of what engine they use. Or excuse me, it's actually a motor, not an engine, because an engine has moving parts and the motor doesn't.
Yeah.
Anybody want to take what motor they're using for this?
Right.
So.
I do know that it's actually a hybrid between liquid and solid, so that's actually really cool. I don't know the name of it, but I remembered researching that it's actually really cool that they went with both a hybrid of both a liquid and a solid for multiple reasons, because actually a liquid one is a lot easier to control when it comes to like once they're actually in flight, they can stop it at any time, they can start it again, whereas you have the solid, which is actually a lot more reliable. It's been used longer. I'm sure Space Mike would be able to take up on why solid is a bit better, but that was cool. So I know the answer. It's a hybrid of both. So that's really cool. It's also called VSS Unity, by the way. I don't know if anyone knew that. By Professor Stephen Hawking is also the name of Spaceship too. But Space Mike, do you know more about the engine itself?
Yeah, it's really interesting with the hybrid. The solid fuel is really easy to store as long as you don't put it around a bunch of flammables and stuff like that. So the solid fuel on this rocket is the fuel for it, and then the liquid fuel isn't actually the fuel; it's the oxidizer for it. So I don't know what chemicals they're using. I'm guessing that's probably proprietary at this point, especially since they had to redesign it so much. But they have said that even with this flight, that even though this was the highest and fastest they've ever gone, they're going to keep going further. This wasn't actually a full duration burn of their motor. So the amount of time that people are going to get, like right now, if people were on that flight, they would have gotten a couple of minutes of weightlessness, but maybe not even enough time to really unstrap, float around and do what you want and strap back in safely. But on those higher flights, we might not even have to be arguing about the semantics of, whether or not they reached 83.7 kilometers, because they might be able to reach a higher altitude, especially if they're with the weight that they had simulated on this flight is actually going to be the weight that a full up operational flight will actually be at. So it's really interesting, and I think that hybrid motors are really, really crazy, and it's interesting though that they're not really used a lot more.
Yeah, and I just kind of want to add on to that about the atmosphere and the Kármán line, and this is going to become our new Pluto, is it a planet debate for 2019, which is that, the atmosphere, there's no point that you can define this is where it stops. It's very fluid, it's very dynamic, and we're in a solar minimum right now, and the sun really does actually end up affecting just how high up the atmosphere goes. So because we're in a solar minimum right now, I would say that, some of the studies that have come out, I know there was one from the Smithsonian Harvard Astrophysical Institute that came out this year from Jonathan McDowell that basically said we should set it at 80 kilometers. Here's why. And I read that paper, and that's actually what convinced me to basically stop saying 100 kilometers is space, 80 kilometers is space. It really does have to do with a lot of that. So as far as I'm concerned, this flight was to space. So because it crossed 80 kilometers, and that's where I define the boundary. And by the way, the FAI is going to look, because of that paper that was written next year in 2019, they are actually going to go back and relook and see if they're going to change where the Karman line actually is. And there's lots of hints that says that they sure are. So very, very cool stuff with that there. Now, we've got a little bit of surgery to perform today. So who's going to be our doctor for this one? I believe that's you, Space Mike.
We had two Russian cosmonauts that were the doctor for the Soyuz MS-9 spacecraft, the one that had the hole that they discovered that they had that pressure leak at the space station. I think that was back in August that was discovered.
Yes.
And they patched the hole, and the two astronauts went out to go inspect it from the outside. And the two cosmonauts on this were Oleg Kononenko, who just arrived at the International Space Station on December 3rd with the new crew on the Soyuz MS-11 spacecraft, which we can see there. And he was joined by Sergei Prokopyev, who's been up there. He rode on the Soyuz MS-09 spacecraft. And it was really funny at this moment as Oleg Kononenko was first stabbing into the side of the Soyuz orbital module. He's like, I can't look at that, man. That's my vehicle there. Be careful. Be careful. Oh man.
Yeah, look at that. Look at that.
They had to pull away. I mean, just look at all the stuff that is coming out of that. They had to pull all the material away, those thermal blankets, and then there was a layer of fiberglass and a layer of foil beneath that to get to the actual hole, the metal that where the puncture is supposed to be. And the reason why they wanted to do this was to see, after they patched it up with gauze and epoxy and everything, they wanted to see how much material had come through that hole, and they were going to collect a couple of samples and just try to see if they can determine any other possible causes and see if that the whole theory that this was done on the ground or whether this was done in space, and just kind of see if they can get any more evidence as to how this hole was got there in the first place. And it looks more and more like this was done before it launched into space, and obviously we went over that quite a bit when they first discovered it. This isn't a micrometeoroid, but it's obviously the result of the drill. And they couldn't get to it at first. There we go, where they removed a little bit more and are pulling off pieces of that epoxy. But this is just crazy. This is something that we've never seen before. And the crazy thing about this too is that the orbital module, the Soyuz vehicle, is split into three pieces. There's the service module at the bottom that has all the fuel and the rocket that propels it around, and then there's the descent module, the capsule that the astronauts are actually riding inside of, and then the orbital module, the kind of round ball at the top. That gets disconnected, and right now that's Sergei Prokopyev. He's inside the orbital module, pointing out where that hole was that they discovered and where the patch is. That orbital module is disconnected from the top of the Soyuz before they re-enter the atmosphere, and so it's just going to burn up. So it doesn't really matter as far as safety is concerned that they peeled away all those layers of it. And the Soyuz MS-9 spacecraft has been scheduled to return on December 20th of this year, 2018, just next week. And the EVA that this whole surgery lasted about 7 hours and 45 minutes. And just look at some of these pictures of this. This is just insane. I mean, we've never seen a spacewalk like this before.
Yeah, I do remember on the return to flight for the shuttle program, STS-114, that they had one of the astronauts. They saw like a gap filler coming out between the thermal tiles, and they had one of the astronauts go on the arm onto the bottom, of the heat shield of the shuttle. That's the only thing I can think of that kind of compares to this. But they also did not do it with a knife or shears with that as well. So our chat has got some really interesting stuff to say here. BEF says here, let me hold a.
I just did want to go over this photo. This was just a really cool photo, real quick. If we can go back to that, the 4 spacecraft in that photo right there. We have 2 Soyuz spacecraft, a Cygnus spacecraft, and a Dragon capsule.
Oh, dang.
So I just thought that was pretty cool.
Nice shot.
Shot from the ISS.
Yeah, on the cupola. So very, very cool. So then let's jump to the comments real quick. So you have it from BEF in the IRC chat, which is here. Let me hold a sharp knife while in a spacesuit.
Seems legit.
That was slightly concerning, realizing that you could cut.
That's the space scalpel.
Yeah, and I do remember hearing some of the translations were like, Oleg, be careful, something like that. And I was just like, oh my God.
Being too rough with it. Be gentle.
Yeah. Zapfan from YouTube says that. Zapfan says that surgery was quite messy. I do have to say it was rather medieval.
Yeah, like if this were a game of Operation, he would have lost so hard.
Yeah. Bobby Laval says it was not a surgery, it was an attack on there. Sean Sean Devine wants to know what brand of tree trimmer they were using. So they want to buy one now. Yeah.
Oh, you guys.
I think it was a Shure, but it was those handles that are special space handles that you have to get from NASA. So good luck on trying to get that.
That was pretty. It was genuinely entertaining to watch that. I think my favorite one I saw was a tweet somewhere on Twitter. I couldn't find it, but it basically said, and shortly after, the Soyuz woke up in a bathtub full of ice with its kidneys missing. So I was just like, oh, that's.
That was actually. Yeah, that started as a conversation in Discord, actually, from
Oh, okay.
That was hilarious.
Gotcha.
Oh, my God.
You guys are funny.
Yeah, so come to our Discord channel if you want to see incredible comedy
Hilarity.
like that, I guess. So, yeah, so really, really cool. Just want to talk a little bit about one of my favorite missions, real quick, which is the Voyager spacecraft, which have been going for so long, over 41 years now of operation in space. Definitely a lot longer. They were expected to, and Voyager 2 has finally gone interstellar, and it only took it about 18 billion kilometers of travel from the Earth. So how do we know that Voyager 2 has gone interstellar? Because Voyager 1, there were multiple times that Voyager 1 had been claimed to go interstellar, and then it proved that, oh no, actually, no, it's not gone interstellar. Well, that's exactly how we know that Voyager 2 has gone interstellar, was because of all the false positives that we did with Voyager 1 beforehand. So first of all, Voyager 1 went interstellar in 2012, and that was when there was a drop basically to nearly zero charged particles coming from the sun. So it can differentiate the difference between charged particles from the sun and outside of the influence of the solar wind, basically by the amount of energy that's coming from these particles. And throughout 2018, they noticed that the charged particles that were being detected by Voyager 2 were dropping, and then finally on November 5th, as you can see in this chart right here, it flatlined. That was it. No more charged particles from the solar wind going out, because the solar wind's now being hit by the galactic wind of the interstellar medium of the Milky Way, and Voyager 2 is now officially sampling interstellar space. Now, Voyager 1, during its flyby of Saturn in 1981, it took a trajectory past the moon Titan in order for it to study the atmosphere. There were actually two options. They could have flown by Saturn and sent Voyager 1 onto Pluto, or actually gone on to Titan, so they chose the Titan option with it. And then when it did that, it sent Voyager 1 outbound and above the ecliptic of the solar system. So the ecliptic is the plane that all of the stuff is in there. Voyager 2, during its flyby of Neptune in 1989, it took a trajectory past the moon Triton in orbit around Neptune, which then sent it outbound below the ecliptic of the solar system. So what's so significant about that is that we now have two interstellar spacecraft sampling two distinct areas of interstellar space that we're going to be able to basically compare and contrast to, and that's really, really cool. Also, Voyager 2 has more functional instrumentation on it than Voyager 1 has. So we're actually going to be able to get more data based on different things with it. Like, for instance, Voyager 2 has a plasma spectrometer on there in order to measure what the plasma is actually made out of in the environment. That's dead on Voyager 1, so we haven't been able to get that kind of sampling with it there. Voyager 2 is moving right now at about 15.3 kilometers per second, but it's never going to catch up with Voyager 1 because Voyager 1's moving at 16.9 kilometers per second. So it's just basically never going to leave it. By the way, they have technically not left the solar system.
I was hoping you'd say this.
They have just left the influence of the sun's solar wind out into interstellar space. If you want to leave the sun's gravitational sphere of influence, what we call the Hill sphere of the sun, it's going to take the Voyager probes another 30,000 years in order to pull that off. Yeah, so it's going to be a little bit of a
Got some time.
little bit of a time on that.
years.
So yeah, 30,000 years.
Wow.
They are moving fast, but relative to us here on the Earth, not so fast. So, yeah. So, holy moly, right?
That's so interesting.
I'll set an alarm.
It's just amazing that we can still communicate with these
Yes.
craft.
Yeah.
They're just one of the things that I would say on when I was a tour guide at JPL is it's the that we can hear from these craft. It's the equivalent of being able to see a refrigerator light bulb out past the heliosphere.
Yeah.
It's incredible.
Yeah,
that
yeah.
we can hear these spacecraft that far away.
Yeah, and just to mention in the chat, Core Croc is saying we're listening to the Voyagers at the blazing speed of 10 bits per second. Jimber is asking how long can we keep in contact with the Voyagers? We're expecting to keep in contact with the Voyagers to at least 2025, maybe 2030. In there, it's basically going to reach a point where the nuclear power supply on board of the Voyagers are eventually going to run out of power to power the communication package on board. And the Voyagers had a very big and powerful communication package compared to what most exploratory spacecraft are set up with nowadays. And that was because they wanted to get all that data back super fast.
Yeah, if you look at Voyagers, they're all dish.
Yeah, they're basically a big dish with that there. And there was another one in here that I thought was very funny. DL, Marty the Martian DOD says, so Voyager 2 has passed the ultra super mega Karman line. Yes, it has.
Yep.
So, and then another one from Jim Burr, just to answer this really quickly. What is the definition for Interstellar? That's basically, we would describe it as when the solar wind stops and you're entering into the wind of the Milky Way itself. So,
Yeah. Solar wind is coming from behind the craft, from the sun itself.
Yes.
Interstellar is the galactic wind. It's coming from all the different stars, so it doesn't have a clear direction.
yeah, it's just kind of all over the place.
Chaos.
All right, yeah, pure chaos. All right, so we're going to take a quick break, but before we do that, we are going to go and thank our Escape Velocity citizens. These folks give us $10 or more per episode, and they help make the show happen. I mean, everybody who contributes to TMRO helps make the show happen. And there's a multitude of ways that you could do it, even if you are not able to help us out financially. We're always looking for help with things like coding, developing new platforms. Don't forget to like and subscribe to us and ring the bell with that there. Share it with your friends. Let them know that we're going to be on, what we're going to be talking about, and getting excited for the cosmos and other things like that. But if you would like to help contribute to the shows of tomorrow, you can head on over to patreon.com/TMRO. So we'll be right back after this break. There's more tomorrow right after this.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
Hey, and welcome back to the Observation Lounge here at Station 204 to make Ben happy, AOS. So there you go. And we, as you can tell, we have suddenly added on another person to our crew up here, which is Jim Adams.
Hi, Jim.
Thanks. Good to be here.
No time. The former chief technologist of NASA. Jim, you're back.
I'm back.
Yeah, and you've got like a sweet, pretty awesome
amazing.
holiday
Yeah.
shirt, since most of us are wearing holiday shirts
For those
today.
that want to know, I got this at Kennedy Space Center.
Okay, there we
There's
go.
the bang.
So everybody get on your planes, fly into Florida, go to the gift shop, grab it, and head back home.
Or go to the
Actually, I
internet.
should say it was given to me by a friend from Kennedy Space Center. So,
Oh,
Okay.
yeah, very, very
So
cool.
send a friend instead.
that's right.
Yeah,
Get me gifts.
very, very cool. So, Jim, we have sort of like an open book with you today to kind of just talk about like whatever we're talking about.
Well, I want to
and-
say something about that last bit you did.
Yeah.
Sure.
Yeah, so the heliopause, right, and Voyager, right? Yeah, so many people say, well, that's the edge of the solar system. But in fact, there's more stuff out there,
Yes,
isn't there?
absolutely.
There's this thing called the Oort cloud.
Yes.
Yes.
Which is like the very edge of the sun's gravitational influence, right?
Exactly.
And
Yeah.
we estimate that there's like 1 billion objects out there.
Yeah.
And every now and then, the gravity between Jupiter and Saturn and the sun kind of line up on one and gives one of those little objects a tug. And in over hundreds of thousands of years, it comes screaming in towards the sun. and that's where we get comets from.
Yes, absolutely. Yeah, and the Oort cloud extends out about 1 light year in radius
that's
from
a
the sun.
long way. So 30,000 years.
Yes.
You mark it on your calendar. I like that.
Yeah. I'll put it in my
So-
Google Calendar.
Yeah, we're only going to be
10-minute reminder.
we're only going to be waiting 30,000 years. So just put the calendar in your sock drawer and you're good. You're good to go with that. So.
Just have to see which of our current years will
Yeah, I
match
was
up
going
with
to
that
say,
one.
which calendar now in like the past 10 years could you reuse again in 30,000 years?
It's the Mayan calendar.
Oh, that's a good one. I mean, it's effective over a very long period of time.
So, but one of the things that we did with the Stardust mission was we flew through the tail of one of those comets that came from the Oort
It was
cloud.
Comet Vild 2, right?
Right, it was, and so this is a comet that was coming from a region of space where no human, no spacecraft had ever been, and they took samples of the tail of the comet and brought it back to Earth, and the scientists analyzed what we got. Do you remember what we found?
There were a couple of interstellar grains
We
in there, weren't
found
there?
amino acids.
Oh, excuse me. Yeah.
Amino acids in the tail of a comet from a region of space where humanity has never been.
Yeah.
Right? And then just to blow your mind just a little bit more, right? If the astrophysicists can wind the model of the motion of our solar system and our neighboring solar systems backwards and see where our stellar nursery was when our sun was forming. And it seems as though that recently some of the astrophysicists are saying the stars in our stellar nursery were so close together that we shared Oort cloud material.
Wow.
So if we had amino acids in our Oort cloud, and maybe the stars next door have the same amino acids.
Yeah.
So there could be another Jared on one
I
of
hope
those
not.
planets.
That's one too many.
No,
If the other Jared is watching this, I'm after you.
It's like the planet
a
of
Rick and Morty.
I was gonna say
Jared
the
war.
planet of Mortys, man.
Yeah, that's
You gotta get some Ricks.
yeah.
Seriously, if conditions
Mike.
were right, similar
I've been
type
wanting
of
to
life
do this
could
ever
evolve.
since I saw this.
He's our magically disappeared.
Yeah. Anyway, what were you saying, Mike?
I just think that that's incredible. I mean, if those building blocks got shared in our closest neighbors, that possibly similar type of life could evolve if conditions are right.
Yeah, that's exactly why planetary science, a big theme in planetary science is understanding the possibility of life beyond Earth. And that's why investigating Mars is so important and why Europa and Enceladus are all really very important targets as we try and understand how we might have formed, how other life might have formed after us or before us and that sort of thing. So
Yeah, and I think it's particularly interesting too if we do end up finding life in our own solar system. That should be a really good indicator that there's life widespread throughout the universe. Because if it can arise in multiple places in the same system, then it should be a piece of cake for it to happen elsewhere.
Yeah.
Also, I would be really interested to see if there is life in our own solar system off Earth, the similarities or the dissimilarities of that life as well. Is it the same like DNA structure that we have? Is it the same nucleic acids that make it up as well? So, and if it's radically different, holy moly, then then there's going to be just a treasure trove of possibilities. That would open it up even more to something like that.
So I'll tell you a quick story. In 2008 or so, NASA was, Jim Green and I were running planetary science, and we were looking for a new theme. The theme had been follow the water, finding the water on the various destinations, especially at Mars and that sort of thing. It turns out we have a very soggy solar system.
Yes. Yeah.
There's like water everywhere, right?
Yeah.
So,
It's moist.
So we. So we were looking for a new theme, and one of the themes we were trying out was finding life beyond Earth, right? And we had a little bit of funding to go test it with trial audiences. So I went up to Sacramento, and they had put an ad in the newspaper, and they said, want to come have a conversation, we'll feed you dinner. And the people that showed up had no idea what they were going to be talking about. They didn't even know it was NASA. So I was in a conference room like this, only watching from behind a two-way mirror, and the facilitator started explaining to them, well, if NASA were to find life beyond Earth, would that be important? And these are people from grandmothers to junior high schoolers, right? About 40 of them. And they all said, yeah, that would be really, really important. And so he explained to them what Europa was about. Well, if NASA were to find life inside Europa, would that be important? And most of them said, yeah, absolutely. That's an extremely important theme. NASA should definitely go for that, right? And then the last question the facilitator asked them was, well, suppose I told you that the life that NASA expects they might find at Europa is algae. You know, because the likelihood that we'd find human beings is,
That's not happening.
Yeah.
Very slim.
And so almost everybody said, yeah, that's still pretty important, except for one junior high school girl. She raised her hand and she said, well, if it's algae, I'm not interested. You have to bring me a puppy.
Space puppies.
So if I ever own a dog, I'm going to name the puppy Europa, I think. Yeah.
Oh, I thought you were going to name it algae.
We found algae.
I like our little
Algae can be
a little comment from BEF in our IRC chat, which is it's life, Jim, but not as we know it. So working out pretty well with that there. So very cool stuff. And I was just thinking too, you know, up at Griffith, when we talk about comets, we often talk about them as sort of like the delivery packets for the things that life needs. Because I know with the Rosetta mission, they found amino acids at 67P. I'm not going to say the full name of it.
Get us a minkle.
Thank you. And there's, you know, there's water there too, water ice and other things like that. And you know, you need that complex chemistry with water along with the source of energy, either geothermal, where the leading stuff now says, you know, it probably started around a hydrothermal vent as opposed to in a pool around the shoreline.
You telling me the last episode of Star Trek Next Generation lied to me?
Yes. So very sorry, but yeah, it's just so cool that we're able to do that. And I think, you know, the hunt for it's so interesting that we're looking for life, and it's almost like life looks for life. You know,
doesn't it?
Yes.
We're lonely.
We're just like, hey, is anybody else here?
That's such a human thing too,
Yeah.
and I think that's why the whole exploration of, you know, looking for life, even if it's algae or a puppy, I think that's such an innately human thing to want to do. You know,
Absolutely.
It's so beautiful.
Yeah.
And Steve Sharmer from our YouTube chat is saying, if microbes are found anywhere beyond Earth, make sure Space Mike, aka the microbe destroyer, doesn't find out. So, Jim, let's open this can of worms.
Hey, here we go.
Besides the,
I don't know what's coming.
So besides the is Pluto a planet debate that has been
I can solve
raging
that for you right now.
endlessly, and now the solve it.
You almost blew right past
Right, let's drop this mic.
What is it?
Oh man.
It's definitely a planet.
Yeah! All right.
But I would,
that was the show, everyone.
but I would definitely say that the term planet is almost meaninless now that we see what we know about the solar system. There is not any destination in our solar system that we've been to that's been like any other.
Yes.
Right.
You know,
I was gonna-
we have
I-
this fantastic universe that we live in.
Even amongst moons. Like, look at the moons of Jupiter, the four
Or even
Galilean moons. They are not the same. But they're in orbit around Jupiter, but they're not the same. Io's this sulfuric hellscape of this like crazy place. If you make a map of it in a month, it's wrong. Because it's so geologically active. Europa, you know, it's super wet and it's got an ocean, a liquid water ocean that's twice the volume of all of the Earth's oceans combined. Ganymede is sort of like this ice ball that may have an ocean underneath it, but also Ganymede's huge. It has its own magnetic field. And then Callisto is like one of the oldest things,
Super crater.
one of the oldest spherical objects in our solar system, which we just look at like they are
I'm
radically
feeling like
different.
Io's not getting a lot of love either.
I know, right? I would love to see an Io orbiter, but that would also be like we're going to have to build the entire thing out of titanium.
We'll have to finish the Parker Solar Probe mission and then redirect it out there.
Obviously. Yeah. So with that there. So the can of worms that I wanted to open up before we went on that beautiful tangent there, which is that we have
Whole
talked.
idea of microbes.
Yeah,
What did
we
Mike
have.
say?
Yes.
Go ahead, Mike.
The whole idea of microbes, and when talking about Mars, one of the debates that we've had quite a bit is that if we do find microbes that are there that have been some sort of contamination from like the Vikings or something like that, or if we find microbes that are natural to Mars, how do we proceed from there? And if the microbes are something that is from a contamination that we mistakenly put there, then who cares what happens to them? Or if it is something natural, especially since you brought up the whole idea of the same type of building blocks might be all over the place, and it should be right here in our own solar system. If it is some sort of basic type of microbe that is related to microbes here on Earth, do we just leave it alone and Mars is completely off limits, or do we help it out and try to give it improve the conditions so that that life can thrive, so that eventually we could introduce even more types of life and eventually ourselves and have another Earth-like place?
So,
Yeah.
where to even go with all of this? Right? So, is there a question in all of this? I mean, I've got a whole
I
bunch of
suppose.
stories.
Do you leave Mars to the bacteria?
What's your opinion? Yeah. Do you? Yeah. What do you?
Yeah. Okay. All right. So first thing, I still have a steak dinner bet with Jim Green about whether or not the methane plumes we're seeing at Mars are either geologic in nature or microbial metabolism, decay sort of stuff.
And which side are you on?
Well, see, because Jim was my boss, he got to choose first.
Okay.
So in order to have a proper bet, I had to choose the opposite side. So I am on the side of geologic activity, and so I'm rooting for insight. You know,
But had you had the initial option,
Yes.
I probably would have chosen microbes because it's just so
Right.
cool.
Yeah. The whole idea that seasonally the microbes wake up and start metabolizing and produce this sort of really tenuous cloud of methane. And now I'm told that Curiosity has the ability to distinguish between the ratio of the isotopes of methane, and that can give us a clue. But it has to be able to smell it first.
Right.
Yeah. So.
Yeah, and I think if I remember correctly, Curiosity is sort of in a methane deficient area on Mars too.
Yeah.
So.
Yeah, that's right. So so that's the one thing about the methane, and I still haven't got my steak dinner bet solved, and maybe we won't. But,
Maybe 2020.
What do you think?
Yes.
I am really, I'm really very pro human space exploration, and Mars is the next destination, Mike. Yeah, I mean, we'll stop at the moon, but I think Mars is the next destination for humanity, and so that means that the scientists have about 30 years to figure out what they want to figure out about the microbes on Mars. Sorry, I keep losing that.
30 years.
Well, 2030. Oh, I'm sorry. This is 2018. So they got.
Like, is there some mission we don't know about?
I mean,
Sorry.
optimistically
We
less
got
than
12
10.
years. to try to
All
move
right,
forward.
I'll give it. Yeah, Ben is arguing with my math,
How dare you?
but that's okay. Sure, yeah. Between 10 and 30 years before humans start to go back to Mars, and just because you land on, I mean, Mars is a big place. Just because you land in one spot on Mars doesn't necessarily mean you've contaminated the entire planet. But we will leave contamination behind.
That's what we do. We make a mess of
Have
it.
no choice.
really
I
good
mean, we
at
left bags of
we
poop
should
on
be
the moon.
smart about it.
So,
Yeah, we should be smart about it. But we we are going to leave contamination there, and so the astrobiologists and the folks that are looking to see if there are indigenous, homegrown microbes on Mars, they better hurry up.
Yeah, freshly chilled microbes at Mars. So really cool question that I feel like we don't talk about enough from Raj Luthra in our chat room. which is what should be the next destination after Mars?
Oh yeah,
Where should we go after Mars?
Saturn.
Saturn?
Yeah.
Ooh.
Send humans to Saturn?
Yeah, space station around Saturn.
Okay.
Landed
That's-
on Saturn.
So nobody's landing on Saturn.
Like an orbiter?
I mean, Cassini demonstrated that, right? So yeah, so
intentional.
I had the opportunity to roll out a new stamp a few years ago, and it's funny because if you find the pictures on the web, it's like Charlie Bolden is dressed in a suit, and the vice president of the Postal Service is dressed in a suit, and there was the family of Alan Shepard was there, all dressed up, and I had been told, well, it's very casual, so I showed up in this bright yellow polo shirt, right? But
You'll be remembered forever.
that's
So-
where I laid the challenge to the agency to start thinking about exactly that question. What is going to be the next destination? What will we be thinking about once we feel as though we've got a solid foothold on Mars? And I think it's Saturn.
Do you think that the moons of Saturn are
Yeah.
particularly helpful with that?
So-
Like Titan?
Yeah, Titan. So back to one of the things that you were observing. One of the things last week I was talking with Alan Stern, and we were having this conversation about, well, why did Titan get so much methane and Europa get so much water and that sort of thing. And he looked at me and he said, if we knew the answer to that question, both of us would have a Nobel Prize. So, but yeah, I kind of bypassed Jupiter simply because of the radiation.
Yeah, it's incredible.
It's
I mean, it
gnarly.
fries spacecraft.
Yeah.
So,
Yeah.
If you stood on the surface of Europa, you would receive a lethal dose of radiation in 48 hours.
Yep.
Wow.
So,
Oh, I didn't know that.
Not too hospitable.
That's why on a lot of the design studies for a lander on the surface of Europa, it only lasts about 8 to 10 days.
Right.
So yeah.
Yeah.
Pretty
Because it
hostile.
literally fries stuff. So yeah, it's ridiculous.
So yeah, so
Space station around Saturn.
I think a space station around Saturn. Besides, it fits into one of those movies. Which was the movie?
I think it was Interstellar.
Interstellar.
Yes.
Yeah.
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 They first
There you go.
get,
Because that's where the wormhole is, right?
Yeah,
And
they
so-
use Saturn's
Yeah.
gravity to do the wormhole, and then they have like an O'Neill cylinder at some point.
2001 as well? Wasn't it?
So
Yes,
the
in the
story,
book.
the book.
The true story of
Yeah.
the true story.
So expect a wormhole.
We actually had somebody, one of our citizens was asking about Venus. What do you think about
Yeah.
colonies on Venus or
Well,
in the clouds?
Yeah,
around
there you
Venus.
go.
Yeah,
Yeah,
that would
like,
be pretty cool, wouldn't it?
Like
Yeah.
Project Havoc. So,
Oh, that's
which I
right.
just love saying it because Project Havoc.
Yeah.
Like it's amazing. It's so fun to say.
So I really don't. I'm not exactly sure why I never really contemplate going in
Yeah.
towards the sun rather than out towards Mars and Jupiter and
Right.
Saturn. But
Yeah. I mean,
I haven't
Venus.
really given that any thought.
Venus
Humans
is
around Venus.
Yeah.
I
I
mean,
mean,
it's-
if you could figure out a way to harvest the carbon from the atmosphere, then you could start building stations with
Yeah.
material right there.
3D printing a space station around
That would be great.
Venus.
Yeah.
Let's
We
know
know some
a little bit.
I've seen
we know
some
some guys.
amazing concepts of robotic craft to explore Venus.
Right.
These expandable balloons. Saw those at JPL, and then there's a group called VEXAG, Venus Advisory Group, that came up with an inflatable airplane. So it would fly, and then the wings would inflate, and it would jet around the
That's cool.
atmosphere.
Nice.
Yeah.
And
It's got it's close to the sun, so you can solar power it.
it was
Yeah.
solar powered. That's
Yeah.
right. Yeah.
And that is really really cool.
But I like submarines and boats on Titan too.
Yes.
Yeah. Well, there's one of the
Space Center.
is it the New Frontiers mission? The two competitors right now. One is Caesar, which is return to Churyumov Gerasimenko and take a sample and bring it back. And then the other one's called Dragonfly, which is literally land a 6-rotor nuclear-powered drone on Titan and have it fly
Yeah.
around.
That's
so
way
I
cool.
think
Yes.
I think you know which one I'm rooting for. So yeah.
Yeah.
Cool. That sounds so cool. There's sort of Akith Thyron on here is saying, I agree with Jim Burr. How about the asteroid belt? Vesta series? You know, should we be like in the Expanse, a bunch of belters you know, out there?
You know, I don't know why. It's a sort of an emotional thing. I lost my ears. It's sort of an emotional thing. In the same way that I don't think that the moon is really a permanent destination. We might go to the asteroid belt series or Vesta, and then move on to Mars from there. Maybe, I don't know. We'll see.
Wait, why is the moon not a permanent destination?
Yeah. So Ben is asking. So Ben's asking why the moon is not a permanent destination.
Yeah. Good question. You know, I just don't see the resources at the moon that we would need. And I feel as though Mars has a better chance of having resources, and it has a diurnal cycle that's more normally human, you know, that sort of thing. But we'll basically go where the president and Congress tell us to go, right? So
What do you
Moon
think?
would be a good launching port.
Yeah.
it would
What do
be.
you think it'd be
So
useful?
I'm very much in favor of like the Gateway.
Yes.
Okay. Okay, go on.
Oh man, this is the last time I'm ever coming. I'm coming back on your show.
For those of you that couldn't see, Ben just crumpled in pain.
Ben crumpled
Physically
and Mike
hurt him.
raised the roof. So
Don't worry about him. Don't worry about him.
So
Please,
what's
tell me
really
more.
cool about what's happened since I was a kid in 1969 is that space exploration is now open beyond the purview of governments, right? We're seeing commercial space enterprises, we're seeing space tourism start. You know, it won't be long before people are doing at least Apollo 8 style journeys as tourists. I think that's pretty cool.
yeah, the Dear Moon project. For
Yeah.
that. So
Right.
Yeah.
So
It only took us 50 years.
Putting a congregating place in orbit around the moon just seems to make sense, right? A place where, like the space station, where commercial enterprise can use as a destination or a launching point. Commercial entities that want to attempt to mine the moon can launch from and to there, and then NASA can use it as a stepping stone further out in the solar system. So that's why I'm kind of in favor of the Gateway. It just seems like we could talk a lot about putting a space station around Mars, but it'll be talk for decades. We could actually put a Gateway together in 5-7 years, I think, and start using it.
Yeah, and there's already, you know, as Space Mike will point out, there's already a lot of international partners that are on board with the idea of a lunar gateway.
Yeah.
So, and a lot of commercial partners who would definitely be a part of it. And I think, oh gosh, what was the name of the thing that NASA just announced with the lunar? I can't remember the acronym for it. CLIP.
Clip. Yeah.
Yes.
Commercial lunar payload.
Yeah, that. So, the one that they just announced.
Yeah.
Commercial lunar payload services. Yeah.
If Mike is talking, I can't hear him.
Mike is
Your
just saying
ears.
the acronym for
he
it
was
there.
confirming.
So,
Commercial
yeah.
lunar payload service.
Yeah.
Ears. That's okay.
Sweet.
Yeah, that is really, really cool. So I kind of want to ask this because, you know, obviously this came up, this week because of Virgin Galactic's successful flight.
That is just so cool.
I know,
Yeah,
right?
yeah.
Like we're finally here. We're the common man with $250,000 to spare.
It won't be long before it's 25,000.
I know.
And then it'll be
Exactly.
2,500.
My point exactly.
I always tell.
When it's 350,
Yeah.
let me know.
Tree fitting. I always tell kids that I talk to at Griffith when I'm like, yeah, it's $250,000 to go right now. And the kids are always like, oh my gosh, $250,000. And I say, yeah. And you know, if you look at an airline ticket from the 1930s,
Yeah.
and then you compare the price in the 1950s, only the elite, if you will, the financial elite, whatever that is, in the 1930s were able to fly on airplanes. And then by the 1950s, anybody could buy a ticket. And nowadays, it's just a common thing. I could literally pull my phone out and just buy a ticket on my phone. So maybe, hopefully by 2030, I can pull out my phone and just buy my Virgin Galactic flight.
Absolutely.
Because I mean, New Shepard's cool and everything, but it's not a rocket glider. So
I think the other thing that
I'm just saying. So
that the whole commercial space initiative and space tourism brings to the future. We need to lean forward and not worry about how we got here. A lot of people want to create a new space race. I don't think we should have one. I think it should be the evolution of mankind forward. And so when we go, we'll go as commercial enterprise, we'll go as various governments, but we should go to Mars, especially as planet Earth. And I think because commercial enterprise and space tourism will be taking advantage of space that way, it'll be harder for us to create some sort of artificial geopolitical space race, and so I'm from that standpoint, I'm also very much in favor of the whole commercial and space tourism initiatives.
And I'm kind of with you. I don't buy the idea of a space race at the moment between NASA and commercial entities. I know that there's a very big very big narrative from a lot of people that try to say that the commercial space flight's basically going to outdo NASA at every step that it can. And then there's also people who would say, well, no, NASA is, gonna blow everything out of the water with that. But I don't buy any of those for a second. It's that public-private partnership that really helps out.
Absolutely.
For instance, there was just an article written this week about looking at SpaceX was up at NASA Ames looking at heat shield materials. So to improve, to improve upon the systems that they already have. Now, whether it's for their Starship or whatever it's called this week, I don't think that was specified in the article. But there was a really cool thing that talked about that. And the heat shield material for Dragon came from NASA as well. It's just SpaceX took it and improved upon it. So there's
which is the way it should be.
Yes,
Right?
yes, absolutely. And NASA does that really great work and then basically hands it out and says, take this, run with it, do what you need.
Well, I think it's in the purview of governments to do, and this is spoken as a capitalist, right? It's within the purview of the governments to do what commercial enterprise either can't or won't.
Right.
Right? And so people, like on an airplane on the way out, somebody said, well, looks like Elon Musk is going to beat you to Mars. And I'm like, well, I hope he does. Because that means that our job is valid, right?
Yes.
And if that's the case, then we'll move on and we'll go to the next destination.
Or buy seats.
Exactly.
Or buy seats. Absolutely.
Why would NASA not buy seats?
Exactly.
On a mission like that?
I'd want to be. I'm not in the camp of those that would say I'll go with no possibility of returning, though.
I'm not that extreme either.
So I had the opportunity when I was in South Africa to do a lecture tour with a couple of the Mars One selectees. And those people aren't crazy. They're visionary, but they're not crazy. And they asked, the audience would often ask, well, why would Mars One be willing to send people to Mars permanently and NASA won't? And I think it's because it goes all the way back to JFK, send a man to the moon and return him safely. I think that's part of NASA's DNA, be able to come back.
Going there, doing the work, having the experience, and then returning so that you can share that with humanity.
Absolutely.
So, that's kind of a really good way to put it. With that there. So.
And that's why it's important for multiple partnerships as well, because there's different visions that each company or each entity can actually bring to the table. Whereas you were saying, commercial might have one view and then private might have another. And then federal, obviously, like through the government. And and plus too, I think that once you actually start to get to space, then you can worry about the next thing, which would actually start to plan the landing and start to plan, like you said, the next steps.
Right.
So, and I also think that if you have this competition of a space race, this what then brings in like territorialism. You start to have this competition then between
this is my area of Mars, and that's the Russian area of Mars.
You stick to Elysium Planitia, and I'll be over here on the Tharsis
Here's the
Bulge.
line.
Which
This
I feel
side's
like
mine.
we're
that's
moved past.
that's exactly right. As humanity, it would be nice to have moved beyond that.
Yeah.
Yes.
So,
Definitely.
Yeah.
There's
Beyond the whole
Mike?
thing, I mean, just the whole international collaboration. I mean, there's so many different. There's so many different capabilities that different countries have. I mean, the Canadians are best known for a lot of their space robotics hardware. The Russians have very reliable rocket technology. Who knows what the Chinese are going to have their expertise in? The Japanese are really, really good at their data acquisition. So, I mean, there's lots of ways that we can all help each other, all the different federal space agencies around the world, and all the new private companies, because all this stuff is leading to more and more new private companies, not just in the United States, but all over the world. I mean, I've been trying to follow just the rocket startups in China. That's growing so crazy out of control that it's getting hard to follow.
It's fantastic.
But not
isn't
just this whole commercial and government thing, but internationally as well. And what do you think are some of the challenges and ways that we can get rid of some of the restrictions, especially with the laws, to collaborate more internationally?
I'm going to say something really controversial, Mike.
Go for it.
I think the answer to your question is we need a generation of space-aware politicians and diplomats. And I think that UN Copious in Vienna is going to be really key in playing a role in bringing us together so we could do exactly what Mike just said.
And could you just, for our viewers who may not know, UN Copious, what is that?
So it's the United Nations Committee on the Peaceful Uses of Outer Space.
Gotcha.
Right, and they meet twice a year, and they also have an adjunct committee on space law. So if you recall a while back, there was a big, actually it was much more than a while back, 10, 15 years ago, there was a big debate on the Google Lunar X Prize, right? And whether or not when you land, are you allowed to approach the artifacts that the U.S. and Russia have left behind on the surface of the moon? Who owns those and that sort of thing? That's going to become a really big deal.
Yeah.
You know?
Yeah.
In fact, the way the space treaty is working works right now is if somebody goes and mines an asteroid and brings it back to Earth, do they have the right to sell those pieces commercially? Some would say no, some would say yes. I think we're going to end up with space law as a valid discipline as we try and move forward out into the solar system.
Yeah, and we've had a couple people come on to talk about space law. Sort of on the ground floor of getting things started right now. And there's always, as they say, a lot of indecisiveness with the things that are happening.
Well, that's because in law, it's never you never really know exactly what the answer is until it gets tested in a court. Right?
Yeah. Agreed.
Yeah.
So.
Until it hits the road, you never know what's going to happen with it. So it's easier to ask forgiveness than it is permission, right?
Well, I think that's kind of like what visionaries do, isn't it?
Yeah. Go out there and take that risk and
just.
All right, we'll just bring this asteroid close to Earth and see if nobody has a problem with it.
And then Armageddon, the movie was made. It was great.
Yeah. Oops, we've already changed the trajectory. Sorry.
Mine now.
Yeah, exactly. So, you guys have any questions for Jim?
Oh,
I've just been listening.
Yeah, right.
Yeah, I mean, it's always
subjects.
fascinating having you come on, Jim, to talk about some things. Is there something that you're really looking forward to, both in the short term and the long term?
Well, the data results from InSight.
Oh,
I
yeah.
think.
Yes.
Absolutely. I want to know if Mars is quaking.
Yes.
Because that kind of helps my steak dinner bet a little bit. I think the other thing that there's a mission that I think didn't really get enough recognition. It's called MAVEN.
Yes.
So one of the things I've learned recently is on the order of 1 to 2 kilograms of oxygen per second is being sliced off the top of the Martian atmosphere. And so there's a lot of folks that are saying, well, maybe we could terraform Mars and that sort of thing. That's not happening until we figure out how to stop that atmospheric erosion due to the solar wind.
Yeah.
And I've heard a couple of really cool concepts about maybe sending up an artificial magnetic field generator at the Martian L1.
Yeah.
Yeah.
I was going to say, Sarah actually talked about putting a dipole out.
That is it's from the think tank, the conference where NASA posed that to a group of astronomers, to physicists, and they said, how would you stop the atmospheric erosion?
Yeah.
And they came up with dipole.
Yeah.
I, of course, came up with the, before I knew about that one, I came up with the satellite grid.
A satellite grid to deflect the solar wind.
Yep.
Cool.
Channel it around the planet and then maybe use it as an impactor deflector.
Yeah. Yeah. That's great.
And then
I think, understanding that Mars has no coherent magnetic field like the Earth does makes me appreciate the Earth just that much more.
Yes.
I mean, and that's such a great sentiment because, I mean, in terms of like bringing it back down to Earth and translating all of this science for the general public, the more we learn about these extreme worlds or extreme relative to us, the more you can really appreciate how amazing Earth is for us and like how hospitable and congenial things like a magnetosphere. You don't wake up in the morning and say, God, thank goodness that that's still there. The solar winds aren't ruining my day.
You don't.
Yeah, right?
I do.
So much.
We do. Thank goodness.
We should just start a gratitude journal of all the amazing things we've learned about Earth.
Gratitude journal.
I like this.
That's great.
Thank you, Moon, for giving us tides and stable orbit.
Thank
And
you.
No more procession.
Amino acids.
Exactly.
Thank you, cyanobacteria, for the oxygen and causing a mass extinction, which is why I'm now here. Thank you.
Thank you, dinosaurs,
Speaking
for
of
not
mass
existing.
extinction.
Thank you, 6 mile wide asteroid.
For allowing mammals
taking out
to
those
go.
dinosaurs.
So the dinosaurs don't eat us today, right? That's
Exactly.
That's right.
Yeah.
And Mabel ruled the earth.
This is a great idea, actually.
Yeah,
So can you get one of those journals online and review it in your next Thanksgiving show?
yes,
I-
absolutely.
Yes, that's a great idea.
Totally.
Yeah.
Yeah.
I like this.
I like the idea.
Carrie Ann said
If that's there.
community.tomorrow.tv.
Yeah,
We'll start
exactly.
it as a
Head on over. So, Jim, we'll just throw one final question at you from our YouTube chat room from Jim Burr, which is a question for you. If you had the guaranteed budget for one mission with current technology, what would it be? What would you do? What is your
Robotic.
what was that?
Does it matter human or robotic?
Let's do both. Let's do both.
Human, definitely. Let's go to Mars. Let's go do it. We will solve so many problems on that journey that it's not an Apollo redo. And so I think definitely humans to Mars. The second is I'd love to see a submarine inside of Europa.
Yeah.
Space
We're not going
submarine.
to send humans there, but I want to know what's going on inside of there. Why is that water still liquid? And what are those brown stains all about, right? Because when I was just starting out, just out of college, I was a radiation physicist, a space radiation physicist, and when we would test things, organics would turn brown, right? And that's the first thing I thought of when I saw those pictures of Europa was, ice is rifting and the water's upwelling, and so what's turning brown? So
Yeah. Hopefully Europa Clipper spectrometers will determine that.
let's hope so.
It'll be amazing. So,
Yeah, awesome. Europa Clipper is a great mission too.
Yeah.
I mean,
Yes.
the fact that they figured out how to do it non-nuclear is really slick too. I
Yeah,
think.
that's JPL for you.
There you go.
They do the impossible. So.
Absolutely.
Yeah. So, Jim Adams, former chief technologist of NASA, thank you so much for coming on today. Always a
it's a
pleasure.
pleasure.
What is your actual title? Because that's
Yeah.
not it, right?
So I was the deputy chief technologist at
excuse
NASA.
us.
But I was the highest ranking civil servant in technology at NASA. So they would bring in professors like Bobby Braun and Mason Peck and David Miller from Georgia Tech and Cornell and MIT. And they would do 2-year stints, but they would keep the deputies, both the deputy chief technologist and the deputy chief scientist, as sort of the long-term corporate knowledge for that.
Nice.
So yeah, so deputy. But in the when they were looking for new ones, I was the acting chief technologist. So.
Nice.
But
there
I
you
will
go.
tell people that the sweet spot in my career, and probably will be for you, is the second to last job that you have. Right? And so when people ask me what is it that stands out for you at NASA, it was really being Jim Green's deputy, running planetary science. It just is visionary, and we were making news every other week or so, and still are today, isn't it? So I really consider myself planetary. So.
Excellent.
Awesome.
Yeah.
Well, thank you, Jim, for coming on.
Thank you.
And before we head off to our break, of course, we want to thank our escape velocity citizens. These folks give us $10 or more per episode, but also we have our orbital citizens who give us $5 or more per episode. You all help make this show happen. Without your help, we wouldn't be able to do this show. And also the help of people who don't help us out on Patreon. You don't necessarily, like we said earlier, have to actually do that financially. You can actually head over to community.tmro.tv, and a couple of our topics there are how, sort of like speculating how you can help out tomorrow without having to go through Patreon. You can also join our Discord channel and kind of talk with us directly about how you may want to help out the show. And of course, just share the show everywhere, and get the good words of Jim today out to everybody, because this was just such a fantastic interview having you come on today, Jim.
Thank you very much.
Yeah, thank you. All right, and we are going to take a quick break, and when we come back, your comments from last week's show. So stay tuned. There's more tomorrow right after this.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Filled with awesome expectation, this girl's a fascination. And nothing in her way will keep her from her destination. 'Cause she's fire walking, she's fire walking. When it's hot, she keeps on moving. Through the heat, keeps on improving. Yeah, she's fire walking, she's fire walking to be free.
And we're back here on the Observation Lounge now.
ALS.
Yeah. Okay. Thank you for shouting it, Ben. Thanks for that. So nicely done, Ben. That
Graceful as always.
That was not annoying at all. All right, so we are going to talk about previously on Tomorrow. We talked. Got myself laughing again. We talked. Stop! You're making me laugh more. Yes, Dr. Dante Loretta, the principal investigator of the OSIRIS-REx mission at asteroid Bennu, which is there, and just found water on that asteroid, by the way, this week. Just announced that. We are going to go with 2 comments right now. And we're going to start with Athena and then go to Sarah. So Athena, go ahead and give us your comment.
Yes, so this one comes off of YouTube. It is from, I'm going to try to pronounce his name, Stygian5454. And it was at Space Mike. They said, I like the fact that you get enthusiastic about the non-US launches. I think it is easy to get caught up in the US and especially SpaceX launches and focusing on those as the most interesting launches, but I think for the show it is a good thing that you highlight the exciting bits of the non-US launches as well. I like that we actually touched on this very briefly when you guys were speaking about how important it is that every single country brings something different to the table. They bring different expertise, and I think that that's so important to recognize, especially with launches. Last week there was a lot of launches that happened, so last week's show was really exciting, and just the very beginning, there were so many launches you guys were covering, and I just love this comment from this citizen because, I think that so many times, it is easy to get caught up in what SpaceX is doing. I mean, they're doing such groundbreaking things, especially everything here in the U.S., but there's a whole world out there. And, just like, Jim, what you were saying about when we get to space, we should be going as humanity, as, the bulk of people, rather than just thinking, okay, well, NASA's always been it, so that's what it is. Of course, NASA, and then you have all these other companies, and even Space Mike, you were saying China. all these new companies are opening. And so I think obviously recognizing that and spending a lot of time on that is so important, especially so many of you guys are from, like all around the world. So yeah, I love that. And I just thought that comment was really special. So I wanted to share that.
Yeah.
So yeah. So I'm glad everybody, especially during the launch calendar, we get to show who's ahead of all the launches this for this year. So yeah, I thought that was amazing.
Yeah.
I want to share that comment.
That is a good one. I do quite like it.
It was, yeah,
So-
yeah, for sure.
all right.
So yeah.
And then moving on to Sarah, your comment, please.
Oh, my comment is from Rick Vogt on community.tmro.tv. And he said, we had guests over for Thanksgiving, and a phrase brought up by one of my non-space fan friends was ballistic reentry.
Ooh.
Sensing a good conversation starter and having recently built a cross-section build of a Soyuz MS spacecraft.
Nerd.
Yes, rock.
Yeah, Ben just asked if it had a hole in it. So just to get it right. So.
It actually didn't have a skin. There's a picture of it there.
Oh, look at that! That is so cool. Well,
Right?
obviously the problem with this Soyuz is that there's a big hole in it.
So I launched into it. This is back to vote. I launched into a session about how Soyuz worked, its history, the ISS, and its constant habitation for more than 17 years, etc. It was more a fun time and quite interesting how a particular phrase can make it into the minds of the public. And
Yeah.
I just love this. I was wondering if anyone else had any moments where you're just having a conversation with friends and
then a
All the
buzzword.
time.
right? And suddenly you get to be that guy. And
Yes.
it's awesome. And you just nerd out and people are with you because
Yes.
it's a thing that they've already got in their heads. So they're just like, ooh, more information I want to
Yeah.
know.
Yeah.
All the time.
Yeah?
Yeah. Ubers,
Yes.
bars, airports, and it's so important.
Yeah.
That's why I love what's kind of happening here, and then what happens in the forum and everything online, because it's just about having this conversation everywhere.
And that's why reading spin-off
Yeah.
is such an important thing to do if you're a nerd.
Yep. Yeah.
Because
Yep.
it helps you start a conversation with the guy you're sitting next to on the airplane or over Thanksgiving dinner. Autonomous tractors are driven by NASA technology,
Yes.
that sort of thing. So
Yeah, I think my favorite spin-off is the portable filtration systems sent into disaster areas that
Yeah.
were developed from the filtration systems on the International Space Station.
Absolutely,
So, which
yeah.
is pretty amazing. Which also ended up becoming the same type of filtration system I use when I go backpacking. So that way I don't, get parasites and things. While I'm out in the woods.
You don't
so-
die of
especially
dysentery.
important when you find microbes on Mars, you'd want
Yes,
Yeah.
I definitely don't want to drink those. So mostly because I just don't want to hurt them. Unlike some people on this show. So,
Can I
Hydrochloric
plug
acid.
spin-off real quick? It's
Yeah.
www.spinoff.nasa.gov.
there you go.
Love it.
Nice.
Excellent. All
love
right.
it.
Well, that's it for comments, and we're going to wrap up our show by thanking all of our citizens of tomorrow. Yes, that is right. Our escape velocity citizens, you get your names in the show more than us who are actually on the show. So pretty cool.
Super
And then
jelly.
also our orbital citizens as well. You folks also get your name in the show more than we do on the show. But also, we have our suborbital citizens. These folks give us $2.50 an episode or more. And I'm going to stall for time so that you can actually find your name somewhere there. Remember, take your Sharpie out, circle it, and find it. Maybe we should call the suborbital citizens the 80-kilometer citizens or something like that. The Kármán line
Kármán line
citizens or something like that. And then
I like it.
Ben, stop. We have our ground support citizens. These folks give us $1 or more per episode. That's right. All it takes to get your name on the show is $1. And by the way, you're not just getting your name on the show. Like, you're not only just helping out the show, we give you cool things too. Like, you get early access to things, like you actually get to see pre-show, which is kind of like this, where we're kind of messing around, but it's like much more messing around. So it's a lot more
If you
fun.
can imagine that.
Right, to 11.
So, yeah, I think to 12 in this case, because that's
Hangout
one.
tomorrow.
That's one more than 11.
Oh.
What's up?
We have a hangout tomorrow.
Yeah, we do have a Patreon hangout for the folks tomorrow. So if you're on Patreon, you are going to get exclusive access to that. Also, we do have a Discord as well where you can interact with us directly. And we actually have an Escape Velocity channel on Discord just for ourselves and our Escape Velocity patrons. So that way they can like interact double directly with us. And of course, there's lots of ways that you can help out. Like we said, subscribe, head on over to community.tmro.tv and just talk with us. Let us know what you want to see and other things like that. And you should do that because we're awesome.
Yeah,
so
we're pretty cool.
Just
And you're awesome too.
So yeah, and you're awesome too because you're helping get the good word of spaceflight. So next week, what are we doing next week? Well, it's going to be the final show of Orbit 11, which, by the way, it will be the 50th episode this year. We only had 2 weeks where we didn't have an episode. 50 episodes. I think that's a record for us.
Wow.
That's a lot of
on
episodes.
here.
Like 5 episodes ago.
Yeah, we've exceeded
That's
that.
crazy.
Are we going to do like an award show? Or something? Because
would be so
I have
Best of 2018.
what's his name on Twitter? Krusty
We have to
Sea Dog or
celebrate
something?
the rocket champion of 2018.
Yes,
and,
we'll have to crown
Rocket
that.
trophies.
Is
That would
so-
be amazing.
The dollar
Yeah.
exchange.
Yeah, the ceremonial exchange of dollars.
I bet there's rocket trophies.
Yes, just to remind you all, we will not be having a show on December 29th because that's just close to New Year's, and we're just going to take it off. So you could take it off too. Enjoy your rollover from 2018 to 2019, which I am declaring the year of Blade Runner because should Blade Runner happen, right?
There you go.
Well, most importantly, December 31st.
Yes.
Yes.
MU-69.
Yes.
Ultima Thule.
Yeah.
Yep.
Furthest object ever explored by humanity.
Yeah, the first.
Unless you count the solar wind.
Right.
Plasma stuff.
Those
but-
are particles. Nobody cares about particles. Nobody cares about tiny things, right, Mike?
No one cares about that stuff.
Yeah, and also first classical Kuiper Belt object to be explored as
Absolutely.
well.
Yeah.
And I am so hoping that it's like a binary, and I want to know why it's red, and I want to know how accurate the New Horizons navigation team did everything. It's just, holy
So
moly,
much
we're going to be
stuff.
popping bottles for the Kuiper Belt out there. So if you want us to do like an award show or something in the comments, what categories do you want to see? How should we vote on this? I just don't.
This should be something that we should be doing on like the community .tomorrow.tv. That would be
Yeah, we
much
should have
better
started it
for
last month.
Yeah, probably should have done that last month.
Noted. Yep.
Yeah, I'm thinking
Next
about it
year.
now. Yeah. We'll do
trust
it
them.
like 6 months from now. So,
I have
all right, so that is it for Orbit 11.49. Thanks for watching, and we'll see you next week. Bye-bye.